In this lecture, we are going to discuss about the control and status signals. So these signals are used to identify the nature of the operation. There are 3 control signals and 3 status signals. So control signals is nothing but read, write and ALE. Whereas RD stands for read signal. This signal indicates that this selected input or output or memory device is used to read and it is ready for accepting data available on the data bus. And whereas WR stands for the write, this signal indicates that data on the data bus is to be written into the selected memory or input output location. And ALE, it is a positive going pulse generated when a new operation is started by a microprocessor. When the pulse goes high, it indicates address. When pulse goes down, it indicates the data. 3 status signals are input, output or memory, SO and S1. Input output memory, which stands for differentiate between the input output and memory operation. When the signal is high, it indicates input output operation, and when it is low, it indicates the memory operation. S1 and S0 stands for the signal status signals. These signals are used to identify the type of current operation. And also we have the control signals, they are like X1 and X2. These X1 and X2 are called as crystal signals. It is connected at these 2 points and is used to set frequency of the internal clock register. This frequency is internally divided by 2. Clock out, this signal is used as a system clock for the devices connected with the microprocessors. Apart from these control and status signals, we also have the interrupt, that is externally initiator signals. Interrupts are the signals generated by the external device used to request microprocessor to perform a task. There are 5 interrupt signals like trap, RST 7.5, RST 6.5, RST 5.5 and finally INTA, which stands for interrupt. So INTA, which is an interrupt acknowledgement signal used to acknowledge the interrupts when it is raised. Reset in and reset out. These signals are used to reset the microprocessor by setting the program counter to 0. And this signal is used to reset all the connected devices when the microprocessor is set. And next one is ready signal. This signal indicates the device is ready to send or receive data. If the ready is low, then the CPU has to wait, and for ready is high, the CPU has to send the data. Hold signal, this signal indicates the another master is requesting the use of the address and data buses. Hold acknowledgement, it indicates the CPU has received the hold request and it requests the bus the next clock cycle. Hold acknowledge is set low after the hold signal is removed. And apart from this, we have the serial input output signals. There are 2 serial input output serial signals, which stands like SID and SOD. SOD stands for serial output data line. It is used to set or reset as specified by the SIM instruction. And CID stands for serial input data line. The data on this line is loaded into the accumulator whenever RIM instruction is executed. So finally we have control signals, status signals, clock signals, interrupt signals, and also finally serial output signals. So these signals compressed into the architecture of 8085. And apart from this, we have 3 buses like address bus, data bus and control bus. So in the next lecture we can discuss about the timing circuit and machine cycle of the 8085. Thank you. Advantages of 8085 pin diagram. The pin diagram is easy to understand and remember because of its logical and systematic arrangement. It has simple structure with fewer pins compared to the other microprocessor, making it easy to design and implement in electronic circuits. It has dedicated pin interrupt handling, which makes it easy to interfere with external devices that require interrupt driven communication. And we have disadvantages of 8085 microprocessor. It has limited addressing capability due to its 8-bit architecture, which can limit its application that require larger amount of memory. It has limited number of pins, which can be constrained in designing complex systems that require more input-output devices of peripherals. It has separate pins for input or output and memory access, which make it more difficult to design memory mapped input or output circuits.